Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NABIL ISKANDAR, and today I would like to present about my final year research project titled Hazardous Area Classification for Powder Milk Processing Plant. For the introduction, a dust explosion is the rapid combustion in a ventilated location of the small particles suspended in the air. Dust explosion may occur where any dispersed powder, combustible material is present in the air at high concentration. Dust explosion usually occur in various unit operation, including mills, grinders, dryers, and other modes of transport. Dust explosion have been recorded as a large number of accidents in industry since 1785, leading to a significant injury, fatality, destruction of equipment, and loss of property. It is clear that the classification of hazardous area has to do with the formation of potentially explosive atmosphere arising from the dispersion of a fuel combustible dust in the air. For this research, the hazardous area is classified by using standard from International Electrotechnical Commission System for certification to standards relating to equipment for use in explosive atmospheres, or known as IECX standard. For the objective, there are two main two objectives for this research. First of all, it is to identify the hazardous area in the plant, include its equipment, sources, and process use. The second objective of this research is to classify area based on zone and identify potential explosion using IECI standard. For the scope of research, the main scope of the research is to identify the hazardous area in the plant, include its equipment, sources, and process use. The zone classification will be made by referring IECI standard. The classification will be distributed into three zones, which is Zone 20, Zone 21, and Zone 22. This research will be focusing on the dust explosion that could occur in powder milk processing plant. The area classification will be drawn on the process flow of the plant. Next, for the methodology. The first step for the methodology is hazard identification. Hazard needs to be identified to determine which substance and their environmental characteristics are to be classified. In order to determine the hazard identification, it may be necessary to determine if the material is combustible or not, and analyze the material properties such as particle size, content of moisture, minimal cloud, layer ignition, electrical resistivity, and correct dust levels. This section is needed to achieve objective number one for this research, which is to identify the hazardous area in the plant, including its equipment, sources, and process use. Next methodology is the building and equipment layout review. These sections show location and position of all equipment and different types of entry and maintenance area in a specific process or utility field. This technical approach anticipates dangers and potential dangers to prevent them from entering the workplace for the new equipment, method, or system upgrade. This section also needed to achieve objective number one for this research. The next methodology is to evaluate the potential of release source. This section is important because it then provides for an analysis of the detection of possible release sources in such equipment or plant layout. It is then easy to validate the probability of eliminating or reducing them as much as possible. The next methodology is class division or zoning. Areas designated for explosive dust atmosphere are divided into zones which are characterized by the frequency and period of explosive dust atmosphere occurrence. The process flow for powder milk processing plant will be drawn by hazard zone for Zone 20, Zone 21, and Zone 22. Zone 20 is a place in which an explosive dust atmosphere present continuously or for long periods or frequently. For Zone 21 is a place in which an explosive dust atmosphere likely to occur in normal operation occasionally. For Zone 22, it is a place in which an explosive dust atmosphere is not likely to occur in normal operation, but if it does, it will persist for a short period only. This class division is needed to achieve objective number 2, which is to classify area based on zone and identify potential explosion using IECAD standard. The IECAD code is IEC 0079-10-2, explosive atmospheres, part 10-2, classification of area, explosive dust atmosphere. The last methodology is documentation. Documentation is an integral part for hazardous area classification. This hazard classification is then documented, including the equipment rating used in hazardous area for further research. Next, for the result and discussion. From the figure, we can see that the powder milk processing plant layout have been shaded by Zone 20, Zone 21, and Zone 22. The green zone area representing Zone 20, while the red color representing the Zone 21 and Zone 22 been shaded by blue color. This color is to indicate the different hazard zone at the process. From the research, we can see that most of Zone 20 been shaded inside equipments because the process in each equipment will cause dust explosion due to its process characteristic. From the figure also, we can see that raw milk will be kept in bulk storage before going to separator process. The raw milk will be separated to skim milk with 0.15% of milk fat max. Then the milk will undergo pasteurizer process at 72 degrees C for 1 minute. After the process, it will go into the buffer silo. The skim milk then been transferred to preheater process, and it is preheated to temperature between 75 and 120 degrees Celsius. In the evaporator, the skim milk will be converted to powder milk. Before evaporation process, the tint of dust is expected to be below 0.01 mm size in each of the equipment. The expected thickness of dust will be increased after evaporation process due to the particle size of the powder milk. The powder milk will be go to a few process to make the powder milk become finer. The expected dust thickness will be around 0.04 mm at the spray dryer and a packaging equipment. Dust explosion usually occur at dust 0.05 mm size. The distance range for each zone had been identified during the research. Mostly for Zone 20, it will be area inside the equipment. For Zone 21, the zone distance range is 2 meter radius from Zone 20, and for Zone 22, the zone distance range is 3 meter radius from Zone 21. The zone range been made based on standard from zone. The standard zone from IEC code IEC 60079-10-2, part 10-2, classification of areas, explosive dust atmosphere. This figure showed the packer equipment. From the figure, Zone 20 is shaded inside the packer equipment. It is because there are a lot of powder milk product that had small particle size. It is dangerous because it can be a medium for dust explosion to occur. To remove or reduce Zone 20, this process must be control the flow rate out of the packer equipment. It is to reduce the friction that can create heat and could lead to be a trigger for explosion dust. Zone 21 is outside of the packer zone. It is because the powder that dispersed from the packer equipment will be gathered at the outside of the equipment. Housekeeping should be done 1 time in 2 days to prevent the powder stick to the equipment. This housekeeping activity can reduce the Zone 21 to Zone 22, which is more safer. For Zone 22, it is formed outside Zone 21 due to the dispersion of powder milk into the air. This zone can be converted to safe zone by installing ventilation system to prevent the dust dispersed freely into the air. For the conclusion and recommendation, as conclusion for this research, the objective for this project had been achieved, which is to identify the hazardous area in the plant, include its equipment, sources, and process use. And it also achieved to classify the area based on zone and identify the potential explosion using IECI standard. From the result and discussion, the powder milk processing plant had many places that had been zoned by Zone 20, Zone 21, and Zone 22 to avoid possible dust explosion. As recommendation, this plant need to follow this hazard classification to avoid disaster. An important item that affect the continued performance of a dust control system is a proper maintenance. When it comes to maintenance, dust control systems are often overlooked and ignored. Regularly inspect the system to make sure it is operating properly. Ventilation can reduce the quantity of dust in the extracted space, and for small quantities of dust may prevent an explosive dust cloud forming at all. Good housekeeping is perhaps the most important tool we can use to minimize the risk of dust explosion, as it minimizes the volume of combustible dust and the consequence of an explosion. Poor housekeeping creates layer of dust that will act as a source of easily dispersed combustible material. I think that's all for my presentation. Thank you.